Assalamu alaikum friends. I am Taqdees Siddiqui with Computer Graphics as part of Bachelor's in Computer Science course being offered by Virtual University, Government of Pakistan. This is our 29th lecture today, and now we are going to continue our discussion on lighting and shading. Before we took a gap for a couple of lectures and reviewed some of the previous things, we were talking about the mathematics of light and shade. So today we are going to continue our discussion on the same subject. So let's begin. Today we'll be taking a start with traditional three-dimensional hardware accelerated lighting models. To start with, we'll make use of a very simple model, try to develop some basic understanding, and then move from that point onwards. We will now take a look at the traditional method of calculating lighting in hardware, a method that we'll find is sufficient for most of our needs. The traditional approach in real-time computer graphics has been to calculate lighting at a vertex as a sum of the ambient, diffuse, and specular light. Please recollect from our previous discussions that our surfaces have already been divided into triangles. और जब हम triangles की बात करते हैं तो फिर their vertices become important. So calculation of color at any of the vertices of any of the triangles, that in this model's case involves calculation of the ambient, diffuse, and specular light color as a sum. So we sum all the three up to form the final color associated with a vertex of the triangle. Then later on, definitely depending upon what shading we choose to have on our triangles, we will make use of that vertex color value, and maybe flat shading, maybe in case of Gorau we may have a gradient of colors between the two vertices. But to start with, color associated with that vertex would be calculated as sum of the three ambient, diffuse, and specular light. In the simplest form, which is used by OpenGL and Direct3D, the function is simply the sum of these lighting components which are clamped to a maximum color value. So now most of the things would be falling in place. If we have understood what the clamping is, what is the procedure of clamping, and when we require that. So whenever we are going to sum up color values, there is a likelihood of generating values which would be beyond the 0 to 1 range. और जब कभी हमें कोई वैल्यू इस रेंज के बाहर मिलती है, we need to treat that value. Or one of the methods that we can use for treatment of such values is clamping. So this is what we are talking about. We have an ambient term and then a sum of all the light from the light sources. Now please note, the ambient term, we have already defined that as well. We'll be recapping it today as well. That is the environmental light. Add to it the sum of all the light from the light sources. Only the light sources. That's an important thing to be noted. We are not considering light from any other means. Just the true light sources that are being used in our scene, we'll make use of all of them. You are taking a look at the equation right now. I total is equal to KAIA plus sum of KDID plus KSIS. Notice the I's are for the intensities of the ambient, diffused, and specular light, and K's are reflection coefficients. We'll talk about them. So this is what the final equation would be. The total, I total, final color would be calculated as the ambient term, KAIA, plus the sum of the diffused and specular light terms, KDID plus KSIS, considering all the light sources that are available for diffuse light as well as for specular light. Ambient light तो ज़ाहिर है एक दफ़ा ही calculate होगी, the environmental light, और उसके अंदर जितने भी sources हैं सबकी contribute की हुई diffused और specular light जो है उसके sum को भी add कर देते हैं, and that's what gives us the final value. I total is the intensity of light as an RGB value from the sum of the intensity of the global ambient value and the diffuse and specular components of the light from the light sources. So as I said earlier as well, that we are considering all the light sources in order to calculate the diffused and specular components of light. and we are adding to it the ambient component, which we calculate for the whole scene globally. That is why we call it global ambient value. Now this is called a local lighting model, since the only light on a vertex is from a light source, not from other objects. That is, lights are lights, not objects. So what we mean to say is that this model is making use of the light from light sources only. इसका मतलब यह है कि जहाँ कहीं भी diffuse light या specular light source available है, that is considered and being accounted for. अगर किसी ऑब्जेक्ट से कोई लाइट रिफ्लेक्ट होके किसी और ऑब्जेक्ट पे पड़ रही है, या as a result of other lighting on a specific object, it is having some effect or impact on surrounding objects, तो उसे ये मॉडल कंसिडर नहीं कर रहा. We are only concerned about the light sources that are given. Overall ambient light कैलकुलेट कर ली और उसमें तमाम के तमाम diffused और specular light sources का इफेक्ट जो है वो सम अप कर दिया on that vertex which is of interest. So इस वास्ते इसको हम एक सिंपल लोकल मॉडल कह रहे हैं, because it is not talking about any indirect lighting. It is only talking about the direct sources of light and the ambient light, which is overall light in the environment. So we have included the reflection coefficients for each term, K for completeness, because we are not making use of these for the moment. अभी तक जो हमारा मॉडल है, that is not talking about these, that is only talking about the intensities. सिर्फ हम I's ही इस्तेमाल कर रहे हैं, ID as well as IS for diffused and specular lights, and IA for the ambient light. लेकिन in order to keep the model complete, जो reflection coefficients हैं उनको भी इस equation के अंदर account for कर लिया गया है, so that when, as and when we make use of that light, we'll be able to accommodate in the same model as well. The reflection coefficients are in the 0 to 1 range and are specified as part of the material property. Of course, reflection जो है ये तो related है material के साथ. हम इससे पहले at length discuss कर चुके हैं कि अगर material जो है वो एक ख़ास type का हो तो उससे किस तरह की light reflect हो रही होगी, और वो फिर in turn किस किस्म की light contribute कर सकता है to its surrounding objects. अगर एक ऑब्जेक्ट जो है वो इस तरह का है जिसकी ओवरऑल सरफेस जो है वो बहुत स्मूथ है, एंड दैट रिफ्लेक्ट्स मोस्ट ऑफ द लाइट दैट फॉल्स ऑन इट, उसका इम्पैक्ट डिफरेंट होगा कंपेयर्ड टू अनदर ऑब्जेक्ट विच माइट हैव रफ सरफेस बट इवनली रफ सरफेस दैट रिफ्लेक्ट्स लाइट इन ऑल द डायरेक्शंस इक्वली, उसका इम्पैक्ट डिफरेंट होगा. इफ देयर इज अनदर ऑब्जेक्ट विच absorbs most of the light that falls on it, impact naturally is going to be different. So these reflection coefficients, they are specified as part of the material property on which the light is shining. This equation does fail to take into account any gross roughness or anything other than the perfect isotropic reflection. Inherently इस मॉडल के अंदर हम बात जब करते हैं तो सिर्फ जो evenly spread होने वाली light है from a surface, rough surface which is even in the manner that whatever light falls on it gets reflected in all the directions equally. So that is the kind of surface that this model works well for. But for all other cases, it fails. The surface is treated as being perfectly smooth and equally reflective in all directions, right? The same idea. The presumption is model के लिए यह है कि the surface on which the light is shining, that is perfectly smooth and is equally reflective in all directions. जो लाइट इस पे पड़ती है वो तमाम डायरेक्शंस में equally reflect हो जाती है. This is an important characteristic of the surface which is used for this model. Thus this equation is really not good at modeling the illumination of objects that have anything other than a smooth surface, like fur or sand, or a surface that doesn't really reflect light uniformly in all directions, like the brushed metal, hair, or skin. So you see, the model has its limitations. Would work fine for the objects that have the concept of equal reflection in all directions, but would not work for others. If we have an object that is just like a metallic brush paint, or it is sand, or human skin or hair or fur. Think of such objects which reflect light unevenly in multiple different directions. So for all such cases, this model fails. This would not be able to take care of them, because presumption यही है कि जो ऑब्जेक्ट है हमारा उसकी सरफेस ऐसी होगी जो कि इवनली लाइट को रिफ्लेक्ट करेगी in all the directions. And if that fact is maintained, the model works well. However, with liberal use of texture maps to add detail, this model has served pretty well and can still be used for a majority of the lighting processing to create a realistic environment in real time. Being simple, model बहुत ज़्यादा efficiency के ऊपर हमारी भारी नहीं है, hamper नहीं करता. We are able to make use of the model in real-time graphics, and we can generate some realistic views and environments in real time, making use of a concept of texture mapping. क्योंकि इसके लिए हमें कोई indirect lights जो कि other objects से reflect होती हैं उनको account for करने की ज़रूरत नहीं होती. So we can make use of this model wherever we have the texture mapping applications. Surfaces की details को किसी और bitmap के ज़रिए से हमने map करके दिखाना है. For instance, हमने initial examples में देखा था that making use of a teapot and mapping onto it a bitmap of a human figure or some other pattern. That is a very typical example of it. So if we are making use of that concept, so this model can suffice. Let's take a look at the individual parts of the traditional lighting pipeline. जो चीज़ें contribute करती हैं towards the making of this comprehensive lighting model, which is the most simplest thus far. The first one, ambient light. We have talked about this light, ambient light, the environmental light, which is not dependent upon a particular source, but is just there. The light that is just there, that is known as ambient light and is primarily calculated. Ambient light is the light that comes from all directions. Thus, all surfaces are illuminated equally regardless of orientation. So when we talk about the ambient light component, ambient light, regardless of orientation of an object, किस तरह से पड़ा हुआ है, किस एंगल पे रखा हुआ है, एंगल ऑफ व्यू क्या है, this light is going to be there equally for all the objects in our scene. हमारे मॉडल के अंदर, हमारे सीन के अंदर जितने भी ऑब्जेक्ट्स होंगे उन सब को एक ही तरीके की एम्बियंट लाइट मिलेगी for a specific environment. So this is the light, as I said, which is there for every part of the scene, for every object, is not dependent upon any specific source. In general, we can tell that this is light coming from all the directions, which is becoming part of the whole scene from all the directions, not a specific light source like a spotlight or a specular light or a diffuse light for that matter. Take a look at this picture. Ambient light results in a view like this one. If we are looking at a teapot in any given scene, calculating the ambient light would only give us an image like this one. Now, don't have any surface details over here, you can see, right? So ambient light provides illumination but no surface details. आपको ये पता नहीं चलता है कि कर्व किस एरिया में है, कौन सा एरिया जो है वो शार्प एज है, कौन सा एरिया जो है वो स्मूथ है, और लाइट की डिस्ट्रीब्यूशन एज इफ इट इज फॉलिंग ऑन एन ऑब्जेक्ट एंड इज क्रिएटिंग सम शेडो, वो यहाँ पर दिखाई नहीं देती. वी आर मेकिंग यूज ऑफ द एनवायरमेंटल लाइट विच इज जस्ट देयर, एंड मेकिंग यूज ऑफ दैट लाइट what we come up with as a resultant is an image like this one. So that's what we're going to have, making use of ambient light. We can see that it's difficult to make out details or depth information with just ambient light. Ambient light is not enough. It helps us see the objects, but it is unable to create any depth information or surface details. Surface के smooth या coarse होने के बारे में कोई इन्फॉर्मेशन हम नहीं दे सकते, उसके एब्जॉर्बेंट ऑफ लाइट या रिफ्लेक्टिव होने के बारे में कोई इन्फॉर्मेशन हम यूजिंग एम्बियंट लाइट नहीं दे पाते हैं. एम्बियंट लाइटिंग इज आवर फ्रेंड विद इट वी हैव मेड एंड वी कैन मेक सीन्स सीम मोर रियलिस्टिक than they actually are. Default light environmental light, which is just there. We make use of it in order to identify all our objects that are there, and we are able to see them. Although, in order to add depths or details, we'll have to make use of other sources. A world without ambient light is one filled with sharp edges of bright objects surrounded by sharp, dark, harsh shadows. This is the ambient light which makes everything so evenly smooth. A world with too much ambient light looks washed out and dull. अगर हमारे पास सिर्फ ambient light ही हो and all over सिर्फ ambient light का इस्तेमाल किया जाए तो किस किस्म की पिक्चर्स हमारे सामने आएंगी? वो भी आपने जो इमेज देखा, that was a representative of the fact. तो अगर हम सिर्फ ambient light को इस्तेमाल करेंगे तो naturally we are going to lose on details of the objects. उनकी depth का idea, surfaces की details will be missing out on them. And missing out on those details leaves very dull looking images, and that would definitely be something not that we would be wanting to have at the end of the day. The diffuse light, that's the next that we make use of in this pipeline. Diffuse light, we have talked about it earlier on as well, the one that is evenly distributed, evenly reflected from the surface of an object. Diffuse light is the light that is absorbed by a surface and is reflected in all directions. So wherever we have this kind of a light, it reflects in all the directions evenly, and we are able to make use of the light in order to add certain details to our objects or surfaces. In the traditional model, this is ideal diffuse reflection. That's what we make use of in this traditional model. We do not talk about other variations in which we have uneven dispersion of light or reflection of light, for that matter, to be precise, but we make use of the scenario or case in which this is evenly reflected in all the directions. This is good for rough surfaces where the reflected intensity is constant across the surface and is independent of viewpoint, but depends only upon the direction of the light source to the surface. So make sure that you understand this idea, that this is for rough surfaces where the reflected intensity is constant. Across the surface, if we have constant intensity of the reflected light, there this is going to work well. And this the light is independent of the viewpoint. Viewpoint means that where we look at the object from. If we have our point of view changing, still this light, diffuse light, would not be changing. But the light would be dependent only upon the direction of the light itself, the light source, to the surface. So we actually would be playing with the surface normal and the light source and its direction. Regardless of the direction from which we view an object with a stationary diffuse light source on it, the brightness of any point on the surface will remain the same. What we mean to say is that if we are making use of this diffuse light, the one that we'll be making use of in this model, a simplified version of it, regardless of our point of view, कैमरा कहाँ पड़ा हुआ है, कहाँ से सीन को देख रहा है, या हम किस जगह से ऑब्जेक्ट्स को देख रहे हैं, इस बात से कतई नजर हमारे ऑब्जेक्ट्स के ऊपर डिफ्यूज लाइट सिर्फ लाइट सोर्स, डायरेक्शन ऑफ द लाइट दैट इज बीइंग थ्रोन ऑन इट, and the surface normal, that would be made use of to determine what amount of light is going to be there. हम अगर अपना point of view change कर लें, हमारा कैमरा घूम जाता है सीन में, किसी और तरफ से उन ऑब्जेक्ट को देखना शुरू कर देता है, still this particular diffuse light would remain the same for all parts of the surface of the object for which it is calculated. Unlike ambient light, the intensity of diffuse light is directional and is a function of the angle of the incoming light and the surface. As I said earlier, determination किस तरह से होगी intensity की, diffuse light की, that it would be defined as a function of the angle of incoming light and the surface on which it is being shown. This type of shading is called Lambertian shading after Lambert's cosine law. The law states that the intensity of the light reflected from an ideal diffuse surface is proportional to the cosine of the direction of the light to the vertex normal. Since surfaces को तो हमने divide कर लिया है into triangles, that is why वर्टेक्स जो हैं वो बार बार हमारी इस डिस्कशन में आ रहे हैं, दैट wherever we are dealing with surfaces, we are dealing with surfaces decomposed into, making use of the concept of tessellation, decomposed into multiple subcomponents, triangles, और triangles के फिर हम vertices ही को कंसिडर करेंगे. एक पर्टिकुलर वर्टेक्स पे जो हम लाइट कैलकुलेट करने जा रहे हैं, डिफ्यूज लाइट, तो उस वर्टेक्स पे जो नॉर्मल है उस पर और जो डायरेक्शन है लाइट की उस पर डिपेंडेंट होगी फाइनल इंटेंसिटी ऑफ द डिफ्यूज लाइट. एंड अकॉर्डिंग टू दिस कोसाइन्स लॉ, एज वी हैव जस्ट सीन, दैट the intensity of light reflected from this ideal diffuse surface is proportional to the cosine of the direction of light to the vertex normal. Since we are dealing with vertices here and not surfaces, each vertex has a normal associated with it. Therefore, the model will be helping us calculate this diffuse light for each of the vertices individually, separately. हर एक वर्टेक्स पे अपना अलग नॉर्मल होगा, हर एक वर्टेक्स के नॉर्मल को यूज करते हुए हम उस वर्टेक्स पर डिफ्यूज लाइट कैलकुलेट कर सकते हैं. अब आप इसे देखिए, द इलस्ट्रेशन दैट यू आर लुकिंग एट राइट नाउ, डिफ्यूज लाइट डिक्रीजेज एज द एंगल बिटवीन द लाइट वेक्टर एंड द सरफेस नॉर्मल इंक्रीजेज. आप देखिए, द पॉइंट फ्रॉम विच द लाइट इज बीइंग स्प्रेड रिफ्लेक्ट हो रही है इक्वली ऑल डायरेक्शंस में. सरफेस का नॉर्मल और लाइट का जो एंगल है, अगर वो बढ़ता है तो उसके साथ इंटेंसिटी ऑफ डिफ्यूज लाइट कम हो जाती है. टुवर्ड्स राइट आपको जो पॉइंट्स दिखाई दे रहे हैं, दे आर इंडिकेटिव ऑफ द सेम. अगर पॉइंट जो है हमारा नॉर्मल जो है उसका एंगल विद द पॉइंट, द डिफ्यूज लाइट पॉइंट सोर्स, वो कम है तो इंटेंसिटी ज्यादा है, और जब ये एंगल बिटवीन द नॉर्मल ऑफ द सरफेस एंड द डायरेक्शन ऑफ लाइट, ये एंगल ज्यादा हो रहा है, बढ़ रहा है, तो जो जो ये एंगल बढ़ता जाता है इंटेंसिटी ऑफ डिफ्यूज लाइट घटती जाती है. Now this figure shows the intensity of reflected light as a function of the angle between the vertex normal and the light direction. As I said earlier, हम वर्टिसेस की बात कर रहे हैं, उन ट्राइंगल्स की जो कि हमारी सरफेस ऑफ द ऑब्जेक्ट को मेक कर रहे हैं, जिनको हम देखना चाह रहे हैं कि वो डिफ्यूज लाइट के इफेक्ट के तहत क्या कलर लेते हैं. सो हर एक वर्टेक्स पर कलर कैलकुलेशन के लिए जो हमारे पास तरीका है, उसमें हम ये देखते हैं कि नॉर्मल ऑन दैट वर्टेक्स का एंगल जो लाइट के साथ बन रहा है वो अगर कम है तो इंटेंसिटी लाइट की ज्यादा है, और जो ही ये एंगल बढ़ना शुरू होता है इंटेंसिटी ऑफ द डिफ्यूज लाइट स्टार्ट्स रिड्यूसिंग, डिक्रीजिंग ऑन दैट वर्टेक्स. लुक एट दिस इक्वेशन फॉर कैलकुलेटिंग द डिफ्यूज लाइटिंग. वी से ID is equal to n dot L times MD piecewise multiplied by SD. We'll take a look at these components closely. ID is equal to n dot L times MD piecewise multiplied by SD. Diffuse light term is now multiplied by the dot product of the unit normal of the vertex and the unit direction vector to the light from the vertex. Note the direction from the light. The final resultant, diffuse light shading, brings out some surface details, as you can see in this image, right? Compare it with the image that we got from the ambient light. Ambient light वाले image के अंदर हमें surface details बिल्कुल भी नहीं मिल रही थी. We did not get to know which part was actually having a curve, a groove, a darker area or a lighter area, but this diffuse light shading has resulted in an image which is giving us fair amount of details about the surface of the object. You can see that clearly in this image. The problem with just diffuse lighting is that it's independent of the viewer's direction. When we make use of diffuse lighting, the resulting lighting that we get at a vertex is calculated independent of viewer's direction, independent of the angle of view, independent of the position of the camera. Regardless कि हम देख कहाँ से रहे हैं, calculation of light जो है वो constant रहेगी. अगर किसी वर्टेक्स के ऊपर आपने एक लाइट, डिफ्यूज लाइट की वैल्यू जो कैलकुलेट कर ली है, तो वो वैल्यू चेंज नहीं होगी इस बात से कि हम उस ऑब्जेक्ट को किस तरफ से देखते हैं, किस एंगल से देखते हैं. वी आर लुकिंग एट इट maybe at 90 degrees angle or at a greater or a lesser angle, hardly matters. We are looking at it from top or from sides, hardly matters, because calculation के अंदर we do not account for the viewer's angle, the direction from which the object is being viewed. तो जब उस चीज़ को हम अकाउंट फॉर नहीं करेंगे तो नेचुरली जो कैलकुलेशन हमारे सामने आएगी उसके अंदर उसका कोई हाथ नहीं होगा. तो व्यूअर की डायरेक्शन जितनी मर्जी हम चेंज कर लें, ये डिफ्यूज लाइटिंग कैलकुलेशन चेंज नहीं होगी, इट वुड रिमेन द सेम. तो अगर हम कैमरे को घुमा भी देते हैं अराउंड एन ऑब्जेक्ट तो भी द डिफ्यूज लाइट कंपोनेंट इज नॉट गोइंग टू चेंज, बिकॉज इसकी कैलकुलेशन में व्यूअर एंगल जो है वो कोई रोल प्ले ही नहीं कर रहा. Thus, as we change the viewing angle to a vertex, the vertex diffuse light value never changes. It remains the same. We have to rotate the object or move the light to get a change in the diffuse lighting of the object. So if at all we want the diffuse light of an object to change, तो हमें क्या चेंज करना पड़ेगा? व्यूअर एंगल चेंज करने से तो कोई फर्क नहीं पड़ता. We'll have to change the normal direction. ऑब्जेक्ट को रोटेट करें, ऑब्जेक्ट को मूव करें, ताकि उसके सरफेस नॉर्मल्स जो हैं, when we are considering any specific triangle, तो उसके वर्टेक्स का जो नॉर्मल है, अगर उसकी डायरेक्शन चेंज होती है, then the value of the diffuse light can change. और similarly अगर हम लाइट डायरेक्शन चेंज कर दें, जिसको यूज किया जा रहा है हमारे सीन में, then we can change the diffuse light, because diffuse light की कैलकुलेशन के अंदर यही दो चीजें हैं जो कॉन्ट्रीब्यूट कर रही हैं. The object's orientation, if that is changed, if object is rotated so that its surface normal has a different value, and if we change the light source, then only we can have a different value for diffuse light. Otherwise, अगर ये दोनों चीजें सेम रहें, कांस्टेंट रहें, तो हम लाख मूव करते रहें अपने व्यू पॉइंट को या कैमरा को, impact on diffuse light calculation would be zilch, zero. However, when we combine the ambient and diffuse, as we are going to see in the next figure, we can see that the two types of light give a much more realistic representation than either one does alone. So अगला काम हम क्या करने जा रहे हैं? एम्बियंट लाइट हमने कैलकुलेट कर ली, डिफ्यूज लाइट कैलकुलेट कर ली, रिगार्डलेस ऑफ इट कि एम्बियंट लाइट की अपनी लिमिटेशंस क्या हैं, विच आर नोन, कि वो हमें सरफेस डिटेल कोई नहीं दे रही, डेप्थ की इंफॉर्मेशन अबाउट द सीन कोई नहीं दे रही. इट्स ओनली गिविंग अस द ऑब्जेक्ट्स as they would appear using the environmental light, the light which is there by default. और diffuse light के बारे में हमने देख लिया कि वो हमारा एंगल ऑफ व्यू चेंज होने से उस पर कोई फर्क नहीं पड़ रहा. बट स्टिल इन लिमिटेशंस के बावजूद अगर हम एम्बियंट लाइट और डिफ्यूज लाइट दोनों को मिला लें, इनका कंबाइंड इस्तेमाल करें फॉर डिटर्मिनेशन ऑफ लाइट एट अ वर्टेक्स, देन वी हैव अ रियलिस्टिक व्यू. द वन दैट यू आर लुकिंग एट राइट नाउ has been created making use of both ambient and diffuse light together. Do you see any difference between the earlier ones and this new image? सबसे पहले वाले के अंदर सिर्फ आपको आउटलाइन मिली थी, ये पता चला था कि हाँ ये ऑब्जेक्ट जो है ये कोई टी पॉट जैसा लगता है. सेकेंड वाले में we saw some details added, और इस थर्ड वाले में हमने ambient और diffuse दोनों को मिलाकर के इस्तेमाल किया है, so we are getting a much more realistic view of the teapot. There's more intensities added to it, which are contributed by the ambient light, as well as the depth part added by the diffuse light, and we can see more of the details of the object. And thus, combining the two, ambient and diffuse lighting, that gives us a more realistic view. When diffuse and ambient terms are combined, you get more detail and a more natural looking scene. The final color is the combination of the ambient and diffuse colors. We have come to know how to calculate them independently. Having calculated the two, we combine them together to give us the final color that we'll be actually showing in the scene. Now this brings us to specular light. We have talked about ambient, we have talked about diffused light, and now let's talk about the specular light. If you would recall, specular light जो है that was light that was shown on objects externally and was giving us even opportunity to have strong reflections, strong specific reflections from specific areas of objects. Specular light is the light from a light source that is reflected by a surface and is reflected in such a manner that it's both a function of light's vector and the viewer's direction. This specular light is different from diffused. Diffused के केस में क्या हो रहा था? जो रिफ्लेक्शन है वो इक्वल है इन ऑल द डायरेक्शंस, लेकिन व्यूअर की पोजीशन जो है वो कोई असर नहीं रखती कैलकुलेशन ऑफ द डिफ्यूज लाइट पे. बट इन केस ऑफ स्पेकुलर लाइट वी आर टॉकिंग अबाउट लाइट विच इज बीइंग शोन ऑन ऑब्जेक्ट, और ऑब्जेक्ट पे रिफ्लेक्ट कर रहा है उस लाइट को, और उस रिफ्लेक्शन को, उसकी इंटेंसिटी को मेजर करने के अंदर हाथ है लाइट का, लाइट की डायरेक्शन का और व्यूअर की डायरेक्शन का. फॉर इंस्टेंस अगर लाइट सोर्स जो है वो किसी ऑब्जेक्ट के ऊपर इस तरह से शाइन कर रहा है कि उसे अगर हम इस तरफ से लाइट थ्रो कर रहे हैं और ऑपोजिट साइड से हम व्यू कर रहे हैं, तो रिफ्लेक्टेड लाइट अगर डायरेक्टली व्यूअर की आई में जा रही है, मैक्सिमम इंटेंसिटी वी आर गोइंग टू हैव फॉर दैट लाइट. लेकिन अगर उसी ऑब्जेक्ट के ऊपर लाइट का सोर्स वही रहे, डायरेक्शन उसकी वही रहे, हम व्यूअर की डायरेक्शन थोड़ी सी हटा दें, चेंज कर दें, तो नेचुरली तमाम रिफ्लेक्टेड लाइट जो डायरेक्टली पहले व्यूअर की आई में जा रही थी अब नहीं जा रही होगी. व्यूअर वुड बी एबल टू सी सम रिफ्लेक्शन बट द इंटेंसिटी वुड बी डिक्रीज्ड. सो स्पेकुलर लाइट is defined as a function of both the light's vector as well as the direction of the viewer. दोनों मिला के contribute करते हैं towards calculation of the ultimate effect of a specular light on an object. This illustration explains it. The light source is shining on the surface, the point of interest के ऊपर जहाँ पे जाके वो throw होती है, वहाँ से reflection उसकी आ रही है in the other direction. अब अगर viewer जो है वो इस reflection vector के opposite बैठा हुआ है, तो definitely would be able to see most of the light that is being reflected off the surface. So the specular light's intensity follows the reflection vector. Most discussions of lighting start with Fong's lighting equation, and that is what we are going to do right now. The Fong's specular light equation is what we are going to talk about next. The Warnock and Romney, they were the first to try to simulate highlights using a cos and theta term, and that is what they did way back in 1969. But it wasn't until Fong-Bui-Tong in 1998 reformulated this into a more general model that formalized the power value as a measure of surface roughness, that we approach the terms that are being used in specular lights today, they are attributed to Fong-Bui-Tong. The Fong's equation for specular light is given as IS equals MS piecewise multiplied by SS times R dot V raised to power MS. The components of this we are going to describe shortly, but take a closer look at them. IS is equal to MS piecewise multiplied by SS times R dot V raised to power MS. Notice the caret signs on R and V. They show that they have been normalized. Look at this illustration. Now, if the light vector is given by L, surface normal is N, and we've got view vector V and reflection vector R, तो इस सूरत में overall हमारी equation जो है वो क्या sense make करती है, we are going to discuss that. Be sure that you understand that we are talking about the specular light, which would be dependent upon, calculation of which would be dependent upon the angle at which it is being shown, the light vector, as well as the view vector. लेकिन light vector पर dependent होगा reflection vector, और साथ ही साथ normal of the surface of the point on which we are shining this light, that would also determine कि reflection किस तरफ होगी. Now this figure shows the relationship between the normal N, the light vector L, the view direction V, and the reflection vector R, as I just said. मेजर डिफरेंस जो है इस केस में वो एक्चुअली द टर्म MS मेक्स, बट उसका इम्पैक्ट क्या है? इट एक्चुअली ट्राइज टू एस्टिमेट द इफेक्ट ऑफ रिफ्लेक्शन ऑफ द स्पेक्युलर लाइट, लेकिन उसकी डिटेल्स को हम नेक्स्ट टाइम डिस्कस करेंगे. फिलहाल वी आर गोइंग टू टेक अ लुक एट व्हाट वी हैव कवर्ड दस फार. वी आर गोइंग टू हैव अ रीकैप ऑफ द थिंग्स दैट वी हैव टॉक्ड अबाउट. Remember that we started off with a most simplified model for lighting, और हमने कोशिश ये की थी कि उसको मजीद simplified terms के अंदर describe कर लें. Let's take a look at that model, recap it, and come to the point where we have described the Phong equation, and we'll take it up next time from that very point. The traditional approach in real-time computer graphics has been to calculate lighting at a vertex as a sum of the ambient, diffuse, and specular light. We started off with this discussion that on any specific vertex of a triangle which is being considered at a point in time, the intensity of light that would be calculated making use of all the three ambient, diffuse, and specular lights. As a result of that, we came up with this equation which said that the total intensity would be given as I total equals Ka Ia plus sum of Kd Id plus Ks Is. So in the first place we calculate the ambient light. That ambient term given by Ka Ia gets added to the sum of all the diffused and specular light sources from all the light sources. So we calculate effect of diffuse and specular light on that vertex from all the sources of light. The point to note in this model is that it makes use of the sources of light, the direct sources of light. Any indirect lights as a result of reflection, they are not made use of when we talk about the simplified version of it. Although in this equation we can see that those reflection coefficients, the K's, they have been included. But in the simplified format, we'll be making use of the I's, the intensities for ambient, for diffused, and for specular light. Ambient light तो पूरे सीन के लिए एक ही मरतबा कैलकुलेट हो जाएगी, और उस टर्म के अंदर हम ऐड कर देंगे diffused or specular light के effects from all the sources that are there in a scene. Now this is called a local lighting model because of the fact that we've just discussed that it only makes use of the light on a vertex and from a light source, not from other indirect light sources. So any object that is reflecting some light off it and is having an impact on a surrounding object, that effect is not accounted for in this model. And that is why we call it a local lighting model. So the lights that are used are lights, not the objects. So the objects cannot start behaving like lights. So as I said, the lights are lights, not the objects. So अगर कोई भी object as a light behave कर रहा है because it is a shiny surface और इसके ऊपर जो light पड़ रही है वो reflect होकर किसी और object पे पड़ सकती है और उसको illuminate कर सकती है. So that is not accounted for in this model. इसी वास्ते इसको local lighting model कहते हैं. Makes use of and considers only the light sources. And other than the light sources, अगर light किसी भी तरीके से indirectly scene को affect कर रही है तो उसको हम इसमें account for नहीं करते. The reflection coefficients, they are in the range 0 to 1 and they are specified as part of the material property. The concept of reflection coefficients being specified as part of material property is that since the type of material determines how that material surface is going to reflect light, that is why these coefficients are defined as part of that property. Depending upon the surface being coarse one or a very smooth one, the reflection would be different. Similarly, for diffuse, we have seen different lights differently behave करती हैं different surfaces के ऊपर. Therefore, the reflection coefficients, they are defined as the material property, the surface property. Now, then we took a look at the components of this traditional lighting pipeline, the individual parts that make up this whole pipeline. इनमें सबसे पहले हमने बात की ambient light की, और ambient light के बारे में हमने ये जिक्र किया कि ambient light is the environmental light which is there, और उसकी मदद से हम सिर्फ अपने objects जो हैं उनको without any details, without giving any surface details or depth information हम उन्हें ड्रॉ कर सकते हैं, उन्हें दिखा सकते हैं. सो एम्बिएंट लाइट की मदद से ऑब्जेक्ट्स जाहिर होना शुरू हो जाते हैं, नजर आना शुरू हो जाते हैं, बट बहुत ही फ्लैट होते हैं, उनके अंदर कोई डिटेल्स, कोई लाइफ जो है जो कि डेप्थ या शेड के जरिए से आ रही होती है वो दिखाई नहीं जा सकती. एंड मगर एम्बिएंट लाइट का फायदा यह है कि दिस इज ऑलवेज देयर इन द एनवायरमेंट, इन द सीन विच एवर वी आर मेकिंग, उसके अंदर डिफॉल्ट में ये अवेलेबल होगी. दिस इज द लाइट विच इज अवेलेबल बाय डिफॉल्ट एंड इज अवेलेबल एज equally reflected light in all the directions for all the objects of the scene. So ambient light की मदद से हम objects की जो शक्ल निकाल सकते हैं, उसके बारे में हमने देखा था कि वो इस तरह की होगी जिसके अंदर depth information नहीं होगी. So it provides the illumination but it does not provide the depth or the surface details of the objects. फिर उसके बाद हमने बात की diffuse light की, और diffuse light के बारे में ये बताया कि this is the light which is in our particular scenario, हमने इस simplified model के अंदर ये रखा है कि it is going to be reflected in all the directions equally. So ऐसी लाइट जो कि तमाम डायरेक्शंस में equally reflect हो रही होगी, उसको हम consider करेंगे as the diffuse light, और making use of it we'll be able to come up with images with greater details. Surfaces के अंदर हम उनकी details और depth की information जो है वो भी include कर सकते हैं because of the diffuse light. लेकिन diffuse light के बारे में हमने कहा कि it is a function defined by or governed by the direction of light and the normal on the surface. Surface को चूंकि हमने divide कर लिया into multiple triangles, तो हम triangles के vertices ही को consider करते हैं. तो हर triangle के हर vertex के ऊपर एक normal draw किया जा सकता है. जब जब इस normal और direction of light के दरमियान में angle बढ़ता है, तब तब फिर हम देखते हैं कि जो intensity है diffuse light की वो उस पॉइंट के ऊपर, उस वर्टेक्स के ऊपर वो डिक्रीज होती चली जाती है. इन इफेक्ट ऑन एनी वर्टेक्स जब हम कोई वैल्यू कैलकुलेट करेंगे फ्रॉम स्पेसिफिक डिफ्यूज लाइट सोर्स, तो उसकी एक स्पेसिफिक वैल्यू होगी. अगर उस सोर्स को हम दूर ले जाएं तो नेचुरली द एंगल बिटवीन द नॉर्मल ऑन दैट वर्टेक्स एंड द डायरेक्शन ऑफ लाइट दैट इज गोइंग टू चेंज, एंड दैट इज गोइंग टू रिजल्ट इन अ डिक्रीज्ड इंटेंसिटी ऑफ डिफ्यूज लाइट. और अगर वो करीब आता चला जाएगा तो ये एंगल की वैल्यू जो है वो घटती चली जाएगी एंड the intensity would be increasing. लेकिन इसके अंदर एक प्रॉब्लम क्या है कि डिफ्यूज लाइट के केस में जो व्यूअर एंगल है, कैमरा जहां से देख रहा है सीन को, या जहां से व्यूअर देख रहा है, दैट डज नॉट हैव एनी इम्पैक्ट ऑन द कैलकुलेशन ऑफ द डिफ्यूज लाइट. बिकॉज उसके अंदर क्या होता है कि जब आप चेंज कर लें अपना व्यू, ऑब्जेक्ट को किसी डिफरेंट एंगल से देखना शुरू कर दें, तो इससे कोई फर्क नहीं पड़ता. ओवरऑल लाइटिंग वही रहती है जो कि इससे पहले थी, क्योंकि वो कैलकुलेट हो रही है एज अ रिजल्ट ऑफ the normal on the vertex and the direction of light. तो जब तक इन दो कंपोनेंट्स में से कोई कंपोनेंट चेंज नहीं होता, तब तक हमारे पास कैलकुलेटेड लाइट की वैल्यू चेंज नहीं होगी. हम अपना व्यू जितना मर्जी चेंज करते रहें, लेकिन ओवरऑल फाइनल रिजल्टिंग डिफ्यूज लाइट वुड नॉट चेंज. और अगर हमें उस लाइट को चेंज करना है तो वील हैव टू चेंज द ऑब्जेक्ट, यानी उसकी डायरेक्शन हमें चेंज करना पड़ेगी ताकि नॉर्मल की डायरेक्शन बदल जाए, या फिर हमें अपने लाइट सोर्स को हटाना पड़ेगा अपनी जगह से, उसको चेंज करना पड़ेगा ताकि डायरेक्शन ऑफ लाइट जो है वो चेंज हो जाए. इन दोनों में से कोई एक चीज जब चेंज होगी तभी रिजल्टिंग डिफ्यूज लाइट जो है वो चेंज हो सकेगी. जो इक्वेशन हमने फॉर कैलकुलेशन ऑफ डिफ्यूज लाइटिंग देखी थी, दैट वाज लाइक ID इज इक्वल टू N.L टाइम्स MD मल्टीप्लाइड बाय पीस वाइज मल्टीप्लाइड बाय SD. सो इसमें MD जो है वो कलर कंपोनेंट है, कलर वेक्टर है, और SD जो है वो सरफेस के रेलेवेंस से है. L इज द लाइट डायरेक्शन, N is the normal on the vertex. So as you can see, the dot product of N and L that is being taken, and we do not have any consideration for the point of view of where the viewer is, the direction of view. That has not been used in this equation, and that is why इसके अंदर वैल्यू की चेंज करने के लिए N या L में से किसी का चेंज होना जरूरी होगा. As a result of diffuse lighting, जो रिजल्टेंट पिक्चर हमारे सामने आई वो इस तरह से जो अभी आप देख रहे हैं स्क्रीन पे, और इसमें आप देखते हैं कि एम्बिएंट लाइट की निस्बत डिटेल्स जो हैं वो ज्यादा हो जाती हैं. वी हैव द कॉन्सेप्ट ऑफ डेप्थ एंड सम सरफेस डिटेल्स एडेड विच वर नॉन एग्जिस्टेंट इन केस ऑफ एम्बिएंट लाइट. लेकिन ambient light alone was not sufficing. The diffuse light, that alone has added some surface details to our object, but अगर हम एक रियलिस्टिक व्यू देखना चाहें तो उससे अभी भी हम कुछ दूर हैं. सो द आइडिया वाज दैट ओके, एम्बियंट लाइट भी कैलकुलेट कर लिया हमने डिफ्यूज लाइट भी कैलकुलेट कर लिया, तो दोनों को कंबाइन क्यों ना कर लिया जाए. सो व्हेन वी कंबाइन बोथ, वी कैन हैव अ बेटर और मोर रियलिस्टिक लुकिंग इमेज as the one that you're seeing right now on your screens. So this image was generated by combining the effects of ambient light as well as the diffused light. Next was specular light. Specular light के बारे में हमने बताया कि it is the light which shines on a specific surface, and the reflected light, that is got something to do with the way we see a specific light's reflection. The angle of the viewer, that is also important. The light, when it shines on the surface, is reflected at a specific angle, and if that matches the angle of the view, then we are going to have greater intensity, and otherwise we are going to have intensity values varying or decreasing. So specular light's intensity follows the reflection vector. And then we talked about the Fong's equation for specular lighting. The equation read as IS is equal to MS piecewise multiplied by SS times R dot V raised to power MS. So यहाँ R जो है वो reflection vector, V जो है वो view vector है, and MS is a term which is not only used over here and also is used as a power of R dot V, जिसके बारे में मैंने कहा था कि हम डिटेल से नेक्स्ट टाइम डिस्कस करेंगे, बट दिस इज द वन दैट ट्राइज टू एस्टिमेट द रिफ्लेक्शन, द वेरिंग रिफ्लेक्शन बिकॉज ऑफ द वेरिंग एंगल्स. एज यू कैन सी इन दिस इलस्ट्रेशन, द L is the direction of light, N is the normal on the vertex, V is the direction of view, and R is giving the direction of reflection of light. So we have talked about this simple model, and we have talked about the pipeline that is involved in making of it, making use of the ambient, diffused and the specular light, and we're going to keep our discussion right over here. We will be talking about the other aspects, the details about the Fong's equation, because this is a very important one. We'll be talking about the components that make up this equation and their role, but that we'll be covering inshallah next time. For the moment, let's call it a day. इजाज़त दीजिएगा, अगली दफ़ा फिर मुलाकात होगी. तब तक के लिए इजाज़त, फ़ी अमान अल्लाह.